So let us write some examples. So we will start with the zero simplex. Zero simplex is obviously a single point. V0. A one simplex is nothing but an edge. Here we orient it from V0 to V1, so lower index to higher index. So 2 simplex is a filled in triangle. So again the orientation, go from lower index to higher index. So V0 to V1, V1 to V2, V0 to V2. So this is filled in. So filled in means it is a convex combination. So later on we will embed this 2 simplex into 3 dimensions and put V0, V1 and V2 as unit vectors and take all their convex combinations, and that would mean a solid triangle. So for a 3 simplex, we draw a tetrahedron. This is a solid tetrahedron. Yeah, it is filled up, it is not hollow. So let us write down the 4 vertices. Now let us give orientations going from lower index to higher index. So I've just shaded it to show that this is solid, it is filled up. So we need to define what do we mean by solid or filled up. So basically you have to take a convex combination of points, and that is pretty much it. I mean, in a line it is very clear. So let us write it down for n plus 1 simplex. So these are points of Rn plus 1. Yeah, it should be Rn plus 1 rather than Rn there. So this Rn is incorrect, should be Rn plus 1. So this is clear in a line, yeah. So line you consider 2 points, 0, 1 to 1, 0. So all points half lie on it. 3 by 4, 1 by 4 lie on it, 1 by 3, 2 by 3. So basically that fills up the entire line. So now, as promised before, I need to talk about a 2 simplex. So I've drawn the 3 axes x, y and z. Now I'm going to draw a 2 simplex. Yeah, so these 3 pink points are V0, V1 and V2. These are unit vectors. So V0, V1, V2, we fill this up, give appropriate orientations, lower index to higher index. So again, this is filled up precisely because of the convex combination. So 1/3, 1/3, 1/3 is obviously lies on the surface, and that is the center of gravity. So I'm just writing about the orientations. It is important to keep orientations into account because this will be very important for homology computations later on. Yeah, we are going to give plus or minus sign to edges, and that will determine kernels and images. So that is why we have given a convention. So what is a face of a simplex? So you start with deleting one vertex of n plus 1 simplex gives us a single n simplex, which is called a face. So you delete one vertex of n plus 1 simplex. So this n plus 1 simplex is often written like this. Yeah, from v0 to vn. So I'm going to write vertex vi here, which is special because we are going to delete it. So the remaining vertices, yeah, so I've deleted vi, so I'm going to write it as vi hat. So these remaining vertices form an n simplex, and this is called a face. So obviously face is corresponding to a deleted vertex. I'll give an example. v0, v1, v2. So we are giving an example of a 2 simplex. It has 3 vertices. I have appropriately oriented it, marking from lower index to higher index. So first you delete vertex v2. So what you get is an edge from v0 to v1, which you can simply write as v0 comma v1. Or to be more precise, you can write it as v0 comma v1 comma v2 hat to show that we deleted vertex v2. Similarly, from v1 to v2, v1 to v2. So you can write it as v1 comma v2 or v0 hat comma v1 comma v2. So now we delete vertex v1, we get an edge from v0 to v2, which you can write as v0 comma v2, or you can write as v0 comma v1 hat comma v2. And that is pretty much it.